In this video, we're going to take a look at how to set up and test Arduino outputs. Let's get started. So we're starting with the program that we had previously created in our video on testing Arduino inputs. If you haven't watched that video, I'd encourage you to watch that one first, as we're going to reuse several of the concepts from that video in this one. Now, to begin with, we're going to go in and we're going to adjust some of our commenting. So I'm going to change this remap the pins from remap pins to remap inputs. And we're going to make some space below here because we're going to remap our outputs as well. Because everything we're building into the program this time are outputs. And the outputs we're going to set up here is we're going to set up our left motor to begin with. So our left motor uses 3 different pins in order to get the motor to operate. We have an enable pin, and that enable pin from our motor controller is the pin that we toggle on and off at a rapid rate to adjust the speed of the motor itself. And then we have 2 direction pins that by changing the direction pins and the combination that they're set to either high or low, we can change the direction that our motor is rotating in. So let's go in and let's define those pins now. So I'm going to create a ENL for enable left, and enable left is tied to pin 5. I'm going to use LD1 for left direction 1, which is tied to pin 7, and LD2, which is tied to pin 8 for direction 2. And then we're going to go down into our void setup, and we need to specify the pin modes for these pins. And all 3 of these are going to be outputs. And now we've gone through and we've remapped our outputs. We've added those pin directions. And what we're going to do now is, because we only want to have the information for our left motor in here to make sure that we're configuring our motor correctly, we're going to use a method called commenting out to disable our serial commands and our integers. And the way that we do this is we just turn these into a comment by adding that double slash in front. In a future video, I will show you a more effective way of doing this using definitions where we can actually turn these on and off. But for this video here, because we're just doing some basic operations, we're just going to use the commenting out method. So what we want to do is we want to drive our motor at maximum speed in order to figure out the direction that our motor is going to rotate. This is just making things as simple as possible. We'll play with controlling speed in a few minutes, but first let's just start by sending the motor to maximum speed. Now, if you remember from earlier, I talked about how the ENL is going to be our speed control. So what we're going to do is we're going to use an analog write, and the analog write command requires us to specify the pin that we want to write to. So we're going to use that ENL, and then the value that we want to put in. Now, this value can range anywhere from 0 to 255, depending on how fast we want our motor to go. Because we're going to do this at maximum speed for testing purposes, we're going to put in 255 to have it run at maximum speed. Then we're going to add in a digital write to set our direction pins high or low, depending on which direction we want them to rotate. I'm just going to start with writing LD1 high while writing LD2 low. And to be honest with you, I don't know what combination is going to cause this to run at a forward direction, so we're just guessing at this point. But what I do know about my motor controller is if I have 1 pin high and 1 pin low, then it's going to rotate either clockwise or counterclockwise. If I have both pins low, it tells the motor driver to coast. If I have both pins high, it tells the motor to brake. So we want to make sure that we have one high and one low in order to get it to rotate in any particular direction. So now let's change our view so we can see the Sumo, and let's send this code to it and see which direction our motors are rotating. Now, as you might be able to see, it looks like my motor is actually going in reverse. So right now it's rotating in this direction, which means that would be having my left motor running reverse. So at this point, I could grab this information and we'll copy this to a notepad or onto a piece of paper. And I'm going to put this into my notepad file here, and I'm going to add a comment that this runs reverse. So let's try flipping that high and low and see if we get the motor to run in the other direction. Keep in mind, you have to have these capitalized for low and high, or they're not going to work. There we go. I've found the direction for my motor forward for my left direction. I can go through now and I can define my right motor and do the same test to get my right motor running in the forward direction. And we'll do that in a moment here. However, what I want to talk about now is why this seems to be going so slow. Now, the reason this is actually going slow is because right now, I don't have my power switch up here. Let's bring this into your view a little bit more. My power switch, if you notice, is actually turned off. So all the power that's driving this motor is coming from my USB. If I turn the power switch on, you're going to see the motor run in fast mode because it actually has power coming from the battery pack. For diagnostics purposes, we don't need this, so I'm going to turn that off. Now let's go in and add in our right motor information, and I'm going to add in all of my commenting as well. Feel free to pause the video at this point to copy this information down so that you have all of the correct definitions for those pins on your Nano. Next, we're going to go in and we're going to add in our right control. So we'll copy this, paste it below, fix our formatting error here, change this to enable right. And let's try send this to our controller and see what our speed comes out to be, or what our direction comes out to be, rather. Now, my computer did not have enough power over the USB in order to drive both motors, so I had to turn on my battery pack. And you'll notice this motor is running in the forward direction, and my right motor is running in reverse at the moment. So we will go in and flip these. So my left motor needs to be low-high, and obviously my right motor needs to be high-low. Send that to the controller again. We've got this motor running in forward, and that motor running forward. So now we can go in and let's play around with the speeds a little. Let's change these from 255 down to 150. That looks like a much better speed in my opinion. Now, if we want to make this a little bit simpler, instead of having our values typed in manually for every single operation, a better way to do this would be to create a variable that can fill in this place. And to do this, we're going to go up into our declarations area here, and we're going to add another section called variables. And let's add in a forward variable. So that 255 that's used to control our pulse width modulation to our motor controller is actually requiring an integer. So we're going to create an integer variable. So we'll say int. And let's call this forward speed. And we want our forward speed to equal, what did we say down below there? 150. We'll add a comment in here so that we remember that this is a 0 to 255. One thing we have to remember about this forward speed declaration is that after these declarations, we need to add that end of line character. If we don't add the end of line, it's going to cause an error later on. So now that we've set forward speed to 150, we can go down here and we're going to change out these 150s to read the variable forward speed. We can then upload, and we will test our value here by turning on the controller. Here we go. We've got that 150. Let's go back up and let's change this down to 100. Upload to our controller. Let's see what our lowest threshold is that we can get our value to run. Let's try 50. Oh, we can drive our motors at 50. Let's try slower. 20. Looks like we're not getting any movement at 20. So let's try 25. What I'm trying to do now is I'm trying to find the minimum speed at which our motor can drive, so I can write all of this information down so I have it available to build my program. I can't drive at 25. Let's try 30. No motion at 30. Let's try 40. There we go. It looks like we can get motion at 40 on at least one motor. My right motor is not giving me motion at 40, so that could be a sign of I need to add more grease to the gearbox because it can't overcome the friction. Or it could be a case of that motor might be weaker than the motor on the left-hand side. So some good diagnosis to do at this point is to figure out what is going to give you forward and reverse for each motor, what your minimum and maximum speeds are. Well, we know the maximum speed is going to be 255 because that's as fast as the pulse width modulation values can be. That's what we're using when we're using an analog write. But it gives us the option here now that we can figure out all of the thresholds. And in the next video, I'm going to show you how to build routines and some logic that will allow us to make some decisions within our program. Thanks for watching, and we'll see you in the next one.